Bears don't get fat by accident. Their body size in late summer, especially as it is displayed at Brooks River in Katmai National Park, is in part the product of determination. They've spent many weeks gaining the body fat necessary to sustain them through winter hibernation. While Katmai is most famous for its brown bears, the park supports some of the highest densities of bears, and the park supports some of the highest densities of bears ever recorded. The success of Katmai's bears is highly dependent on healthy runs of salmon. Hi, everyone. Welcome to this live chat brought to you by Katmai National Park, the Katmai Conservancy, and explore.org. I'm Mike Fitz, the resident naturalist with Explore. And while we watch the webcams at Brooks River, the salmon might at first garner our attention because they serve as food for the bears that we care to watch and find very enthralling. However, they touch nearly every strand in the area's food webs. And during this broadcast, we'll take a close look at the lives of salmon and what they mean to a place like Katmai. Salmon are inextricably linked with the survival of Katmai's ecosystems as we know them. And to begin, though, let's perhaps journey with the sockeye salmon themselves. Let me pull something up to share with everybody. There we are. The salmon are anadromous fish, and meaning they live part of their lives in fresh water and part of their lives in salt water. Salmon experience an odyssey like few other creatures on Earth, and one that illustrates their drive to survive and reproduce. Understanding the life cycle of sockeye salmon is an important first step to understanding the role that they play in the ecosystem. In the Katmai region, sockeye salmon spawn between midsummer and mid-fall, and the earliest spawning takes place in small spring-fed streams while the latest spawning activity happens at the outlet rivers of large lakes, places like Brooks River. Eggs incubate for several months, and larvae hatch in late winter or early spring. The alevins do not resemble their parents, especially initially. They can't swim. They remain in the gravel until their yolk sac is almost completely exhausted. And in springtime, they emerge en masse into the flowing water column. And at this stage, they're known as fry. For sockeye fry, most of those, they'll eventually move to lakes where they'll feed on plankton for 1 to 2 years before they migrate into salt water. And when juvenile salmon make the journey to the sea, they're known as smolt. And this is one of the most dangerous times in their life. Not only are they chased by birds, by fish, by seals and whales, they also experience a remarkable physiological shift that allows their bodies to survive the transition from freshwater to saltwater. And once they're in the ocean, a salmon's life remains somewhat mysterious. I mean, we're land-based creatures for the most part, so it's very difficult to study the lives of salmon out in the sea. And this is where salmon from that are born in Brooks River will eventually get to the ocean. This is the mouth of the Naknek River at Bristol Bay, and there are a few commercial salmon fishing boats in this photograph as well. We know less about salmon in the ocean than really any other time in their life cycle. Stomach contents tell us what they eat, but not about their hunting behavior. Growth rings on their scales record how long salmon spend in freshwater and the ocean, and fisheries biologists have techniques to read those scales, but those scales don't tell them where they went in between. Tag and catch locations provide information about where a salmon is, but not how it got there. So our knowledge of salmon in the ocean is the sum result of pieces of a vast puzzle that fisheries biologists are still working to assemble. Over 2 to 3 years in the Pacific, Bristol Bay's sockeye make perhaps 2 counterclockwise circuits, and they cover thousands of miles per year. And some may even swim as far south as the same latitude as southern Oregon. In June of each year, tens of millions of sockeye salmon begin to converge on Bristol Bay in the world's last great salmon run. More than 80% of the sockeye salmon arrive within a 2-week window. It's a tsunami of fish unlike any other, and it's their return by which the people of the area measure the arrival of summer. If they are fortunate enough to escape the commercial fishing fleet in Bristol Bay, and in fact more than 2/3 of the sockeye are caught in the fishery each year, they make an arduous journey upstream. The sockeye swim into fresh water to spawn at their place of birth, and their journey is guided by the smell of home. On their outward journey, years before, they imprinted on the unique chemical sense of the water that they passed through to arrive in the ocean. Now they follow the scent back to their place of birth. After swimming about 60 miles through fresh water, hundreds of thousands of sockeye salmon enter the 1.5 mile long Brooks River. It's here that they first encounter hungry brown bears and a physical obstacle that they must overcome to succeed in the final journey of their lives. They must jump Brooks Falls. Let's take a closer look at how they do that. At first glance, it looks haphazard, a waste of energy, an uncoordinated effort leading to repeated failure. While a bit of luck might be necessary for salmon to successfully jump Brooks Falls, a leaping salmon demonstrates an intelligence of its environment and great athleticism to surmount a difficult barrier. Every July, hundreds of thousands of sockeye salmon return to Brooks River in Katmai National Park. Halfway through the river, they encounter the 6-foot-high Brooks Falls. For fish that are often only 2 feet long, the waterfall poses a significant challenge, but salmon measure up to the task. Starting deep within a foaming plunge pool, nicknamed the Jacuzzi, salmon encounter a chaos of currents, knowing, in their own way, that they cannot easily gain momentum by swimming against down-plunging water. Salmon identify where the upwelling currents are strongest, and that's where they launch their effort. Where the water rises to the surface, salmon accelerate quickly upward. Like a tailwind pushing a bicyclist, the upwelling water provides salmon with a significant boost of speed, one that seems necessary for them to surmount the waterfall. Almost all successful jumps originate from places where water rises to the surface of the river. Gaining enough momentum is only part of the journey. Their leap must be accurate as well. The moment salmon leave the water, they are at the mercy of gravity. Within the confines of the water, a place where they cannot see the full form of the waterfall, salmon must choose the angle and direction of their jump. The fish have no control over their trajectory once in the air. If they've chosen correctly and have enough momentum to surmount Brooks Falls, then a final challenge awaits. The current is strong and the water shallow at the very edge of the falls. When they hit the water, a moment's hesitation can send them plunging into the pool below. With an instinct to overcome the forces working against them, salmon flap their tails with vigor while in the air, an effort that allows them to begin swimming the instant they hit the water. With a final surge of energy, they accelerate upstream and leave Brooks Falls in their wake. If salmon are anything, they are athletes. After returning from the ocean, they do not eat. Their entire upstream migration and spawning efforts are fueled by the energy reserves that they carry with them from the sea. Salmon demonstrate great determination to overcome the challenge of Brooks Falls, and their leaps exemplify grace and strength in the face of difficulty. A salmon's work is far from over once they leap the waterfall. When the sockeye approach their spawning area, and when the time is right, their bodies transform. No longer are they sleek and silvery fish. Their bodies become deep red, their heads turn green, their backs develop a prominent hump, and their jaws elongate and curve. The transition signals a readiness to spawn, and this is the most important fight of their lives. Male salmon will compete with other male salmon for access to females, and female salmon secure and defend their nesting site from other females. To prepare a nest, a female salmon will turn on her side and fan the gravel with her tail. And when the time is right, and when and with a male at her side, she releases her eggs, and the male releases his milk. She then buries the eggs, and females will guard the nest as long as they have the energy to do so. And then male salmon, they'll move on. They'll scour the nearby spawning grounds for other mating opportunities as long as their energy holds. The battle they fight and the energy they expend leave them completely exhausted. There is no return to the sea for these fish. And this is an example of a female sockeye's tail after she has finished spawning. They die after they spawn. It's really kind of like at the end of a round trip journey for them that they'll make only once in their lives. And this is the salmon cycle, if all goes well, that is. It's a dramatic example of an organism's drive to reproduce. And we witness part of that cycle on the bear cams in Katmai. And in death, especially, they solidify a legacy that goes far beyond their ephemeral bodies. Particularly, the energy that salmon are the calories that fuel the survival of many of Katmai's creatures. And to investigate that further, let's begin with the largest salmon predators that you'll find on land, the brown bear. And Katmai National Park supports some of the highest densities of brown bears ever measured. It's, for example, to give you a comparison, Denali National Park is home to an estimated 300 to 350 grizzly bears, while Katmai is home to about 2,200 at last estimate. And Katmai is a smaller park overall. So when salmon are migrating and spawning, bears gather in great numbers along salmon streams. Along the 1.5 mile Brooks River, we've seen more than 100 individual bears in a summer. And this year, we witnessed exceptional scenes like this, where more than 30 bears used the area near Brooks Falls at the same time. And why are salmon so important to bears? The answer might seem obvious, right? Bears are hungry animals and they want to eat the fish. Yet by looking at a bear's yearly cycle and the energy provided by salmon, I think we can get a deeper understanding on just how important salmon are to these animals. Bears hibernate in winter and they survive winter by burning body fat. And salmon are a high-calorie, relatively accessible food. In a lot of cases, bears don't have to work very hard to catch fish. They can wait for the fish to come to them. And salmon at Brooks River that are fresh from the ocean in early summer are exceptionally rich in calories. They contain about 4,500 calories of digestible energy for a brown bear. If you're a large bear who's good at fishing, you can easily take in 100,000 calories per day while eating salmon. And bears make efforts to maximize the amount of calories they ingest. When they're hungry, they'll eat the whole fish, but when fishing conditions are good, bears are more selective. They'll high grade the fish. And that's like a miner looking for the high grade ore rather than the waste rock. Bears select the fattiest parts of the salmon. And bears are good at digesting protein, but they're especially good at digesting fat. So they love to eat the skin, the brain, and the eggs. Those are parts of the salmon that are proportionally higher in fat content than the flesh, the bones, and the entrails. And so we often see bears leaving carcasses behind when they are feeding on a lot of fish. So instead of wasting the fish, it's really a choice that helps them to maximize the digestible energy that they eat. And salmon don't eat when they enter fresh water to spawn. So the longer they remain in fresh water, the less energy remains in their bodies. And after spawning, a sockeye salmon contains about half the amount of digestible energy for a bear, yet they're easier to catch in some cases. So dead and dying salmon become an important food for bears in late summer and fall. And by methodically patrolling slow-moving areas of water near the river mouth, bears at Brooks River can find and eat dozens of fish per hour. At a place like Brooks River, it appears that the majority of salmon carcasses are eventually scavenged by bears. In September and October, there are very few whole salmon available to be found. But how many salmon do bears eat? You know, the short answer is a lot. And it's surprisingly a lot. A study on Kodiak Island found that adult male bears ate on average an incredible 6,000 pounds of salmon per bear per year. And that varies somewhat. You know, some adult males ate a lot less. Some ate a lot more, however. Some on the upper end of that spectrum ate nearly 10,000 pounds of salmon per year. And smaller bears ate proportionally less amount of fish, probably because they just don't have the stomach capacity of the larger bears, and maybe because they weren't able to get access to the most productive fishing spots. But all this food translates to great body size for these brown bears. Kodiak bears have the reputation of being the largest brown bears in the world. And Katmai's bears are really a close second. They rival the Kodiak bears in size in many cases. The average midsummer weight of an adult male in Katmai is between 700 and 900 pounds. In late summer and fall, we routinely see adult males at Brooks River who weigh more than 1,000 pounds. Bears like Chunk and 747, who you're looking at here in the far pool, and the largest bears that we know of at Brooks River are more than 1,400 pounds. It's just not that bears eat salmon and that's like the thing that allows them to get big. It's that they have access to salmon across a wide swath of the summer. In central Katmai National Park, in the Brooks River, Naknek Lake, and Brooks Lake area that we're looking at right here, bears can eat salmon in many locations, and it starts fairly early in summer. For instance, as early as as late June, bears arrive at Brooks River right around the time that the first salmon arrive, and they can start to feed on salmon there, and they fish for salmon at Brooks River throughout most of July. But after that, after the salmon start to disperse throughout the watershed, bears have many other opportunities. By late July, there's actually some spawning events that happen in a small creek that drains off of the east side of Dumpling Mountain. Bears at Brooks River might go to some of the tributaries of Lake Brooks, and there are several tributaries of Lake Brooks where they can find spawning salmon. For example, like the one nicknamed Up a Tree Creek, marked on the map here with the red fish. They may also travel about 12 miles as a bird flies to Margot Creek and fish for salmon there in August. And spawning activity happens there earlier than what you might find at Brooks River. But we've been seeing a lot of bears sticking around Brooks River to fish in August. And then, of course, they're around the river a lot in September and October. And Brooks River really provides most bears with the last opportunity to fish for salmon. So bears have the ability and the opportunity in central Katmai to fish for salmon for months at a time. And that's a remarkable thing, and it allows them to gain such great body mass. Of course, salmon aren't the only bears aren't the only animals that will target salmon. If you can eat it, it's going to be part of your diet in Katmai. And we've been fortunate enough to see several wolves fishing at Brooks Falls. Not commonly, it's not something that we see every day on the webcams, but we have had some remarkable opportunities to see that in action. Minks and otters will also eat salmon. The number of eagles increases along Brooks River when salmon are available. And we don't see too many eagles on the webcams, but trust me, they're there. They're perched on the top of the trees. It's just that our webcams are looking down at the water more often, so we don't have maybe the best opportunity to see the eagles perched on the trees. But if you stand at Brooks Falls, almost every evening on that wildlife viewing platform, you can find bald eagles roosting in the trees nearby. It's just not, what we would classically consider a raptor or a bird of prey that's going to be eating salmon. The gulls and magpies relish salmon carcasses, especially those ones that are left behind by brown bears. If you are a gull, for instance, you don't have the ability to really catch a live fish in most situations. So you're waiting for something else to kill the salmon for you so you can feast on the leftovers. And under the water, salmon are just as important for many creatures. The salmon eggs especially are eaten by rainbow trout and also Arctic char. They will gorge on salmon eggs at this time of the year. So any of the trout that are in Brooks River, their stomachs could be visibly distended by the amount of salmon eggs that are in their bellies and in their gullets. And to illustrate that, the next photo, I think, is a good one to illustrate it, but I do want to give everyone a word of warning. It is of a gutted fish. So that's just a heads up on what you're going to see next. But it's an Arctic char or a Dolly Varden that was caught at Margot Creek, at the mouth of Margot Creek in August or early September. I can't remember the exact timing, but it was caught by a ranger. He noticed that its stomach looked really big and really full, and he was wondering what that fish had been eating. So when he was cleaning it in his cabin, cut open the stomach, and hundreds of salmon eggs poured out. And I think this photo, although it's not the prettiest, it really does help to illustrate just how many salmon eggs that these fish are targeting at this time of the year. We talked about all of these vertebrates that are eating bits and pieces of salmon in different ways, but aquatic insects are also doing this as well. Like caddisflies, they will colonize salmon carcasses and feed on the flesh of salmon in some cases. So aquatic insects are also gaining energy from the fish that arrive each year. And the impacts of salmon are conspicuous. Well, you know, when we see bears fishing for them at the falls or an eagle picking at a salmon carcass, yet salmon might exert a greater influence on the ecosystem in ways that are perhaps difficult to see from our perspective. So don't think about necessarily salmon always as a bundle of energy, but really think about them as uh, like fertilizer. Fertilizer applied to a garden. The annual return of salmon is a burst of nutrients that sustains the growth and productivity of many of Katmai's organisms. Uh, so at first, to maybe explore this concept in depth, imagine an Alaskan lake. And if it's not filled with glacial flour, it's cold, it's clear, there's generally little turnover between the water on the bottom of the lake and the water on the top, unless there's a really strong wind event or during kind of like the normal turnover seasons that you'll find in spring and fall. Most of the time, the water is stratified. So you got warm water on top, colder water underneath, not a lot of mixing. So nutrients which would otherwise support plankton at the base of the aquatic food chains are limited. Now, you can contrast Alaskan lakes and streams with waters of the Bering Sea and the North Pacific, which are much more productive and nutrient rich. And that's because those waters aren't nearly as stratified as what you find in freshwater lakes in South Alaska or the Bristol Bay area. There are gyres and currents, upwelling currents that bring nutrients from the deep sea up to the surface of the water. Of course, there's a lot of sunlight in the summertime that helps to boost the growth of plankton at the base of the food web. And then there's almost like a perpetual low pressure system that hangs off of the Aleutian Islands. And those strong storms coming from the Aleutians batter the North Pacific. And all of those things combine to help keep nutrients in suspension. So again, think of these animals returning from the ocean, not just as a bundle of energy, but a pulse of nutrients, a sack of fertilizer, enriching nutrient-poor freshwater lakes and streams. And the pathways that that their nutrients are dispersed throughout the ecosystem are many and varied. Bears are one of the most important ways that salmon nutrients are dispersed throughout the area. Bears will take their carcasses into the forest. They'll follow bear trails. They'll only eat part of the salmon. They will leave those carcasses behind to be colonized by insects or to fertilize plants. And also, bears are carrying a lot of salmon in their digestive tract. And bears will, as the saying goes, they'll do their business in the woods, on the land, in the water, basically anywhere where the urge strikes them. And at this time of the year at Brooks River, it's actually pretty difficult to walk the trails without stepping in bear scat that's filled with salmon parts. And along the riverbanks, it's loaded with bits and pieces of salmon, and that has direct impacts on the vegetation living in those areas. So it's incredible fertilizer, and studies in different areas of North America have shown that riparian vegetation and even trees grow at faster rates when they're growing along a salmon stream versus a stream nearby that doesn't have salmon spawning in them. And the ways that salmon nutrients are transported throughout the ecosystem, again, they can be kind of physical like that, with a bear dragging salmon into the forest or the marshes nearby. But it also happens in different ways as well, with the salmon that are left on the bottom of the stream and they're decomposing there. The biofilm, the algae, the bacteria, the fungus, everything that's down there that colonizes these salmon carcasses, sometimes those miniature creatures, those microscopic creatures, will help to decompose the salmon rapidly, and the nutrients from that decomposition process can be brought into the surrounding water table nearby. In fact, most of the water that's associated with a river or a stream is flowing underground where we can't see it. So that's another way that salmon nutrients are impacting the riparian vegetation. If a plant has roots that can tap the water table directly adjacent to a flowing stream where salmon are spawning, they may be able to directly get salmon nutrients in that manner. So really, we are seeing salmon fertilizing the forest. But when I first read about this, I was wondering, well, is this something that's actually happening, or is it something that we can measure? How are we aware that salmon are enriching the ecosystems in this manner? And how are we aware that the abundance of salmon plays such a vital role in increasing the productivity and growth of vegetation in Katmai's landscape? Think once again and remember once again about where salmon gain most of their body mass. That's out in the ocean. When they go to the ocean as smolt, they weigh maybe a few grams at most. When they come back, they weigh many pounds. So they're gaining more than 99% of their body mass out in the open ocean. And when they're coming back, they're bringing back elements and nutrients that they gained out in the open ocean. And when they're in the ocean, they're actually absorbing different isotopes at different ratios than maybe what they would do if they were living completely in freshwater environments. For example, there's an isotope of nitrogen that tends to be a bit more abundant on land than what you find in the sea, and that's nitrogen 14. But in the ocean, salmon are encountering a higher proportion of a different isotope of nitrogen, and that's nitrogen 15. So by looking at the ratios of nitrogen 14 and nitrogen 15, biologists are able to trace salmon nutrients throughout the ecosystem. And in many areas where salmon return to spawn, they're finding very high and elevated levels of nitrogen 15. And I find this fascinating because these impacts are measurable. Riparian vegetation, as I mentioned before, along salmon streams can be significantly enriched with isotopes that are more common in marine environments. The legacy of salmon is found in the tissues of plants and animals in Katmai. So through simple decomposition, the nutrients from salmon impact the food web in a myriad of ways. We know that salmon are important. We know that they feed animals. We know that they fertilize the ecosystem. So I think it's also important to ponder, what does the loss of salmon mean for areas that are no longer experiencing large runs of salmon? The survival of salmon and the ecosystems they inhabit are not guaranteed. In fact, bears on the Pacific coast of Katmai are not experiencing the booming salmon runs like those at Brooks River. So Brooks River, part of the Bristol Bay run of salmon, which is doing very well right now. But studies that were done on the Pacific coast of Katmai in the last decade has shown that bears in that habitat, like one of their study sites is Hallow Bay, bears are eating a lot more plants and a lot fewer salmon than they were, let's say, 20 years ago. Why this change has occurred is still an open question. This is a couple of brown bears in Hallow Bay. Hallow Bay is an amazing place. One of the most beautiful places that I really have ever been. And on Katmai's coast, sockeye salmon aren't necessarily a common species, but pink and chum salmon are abundant and widespread. At least they're found in a wide variety of streams. And bears are eager to use salmon streams along the coast of the park. But the amount of salmon returning to Katmai's coast between 2010 and 2019 was about half as much as it was during the prior 3 decades. So the conditions that have sustained record high salmon runs in Bristol Bay does not necessarily translate or benefit other salmon species. And I think there's a lot of evidence to support that when we look at how pink salmon runs throughout Alaska in some places aren't doing very well, or especially when you're looking at how salmon runs are faring so poorly in the contiguous United States and parts of British Columbia even. And even if you're looking to parts of northern and central Alaska, how king salmon and chum salmon runs in the Yukon River have done very poorly over the last several years. So when we see how salmon are important to bears, it's really easy to understand their impact. When we start to investigate, though, we see how salmon impact much more. Insects, which in turn feed bears and other animals, the forests and marshes that become more productive because they are fertilized by salmon nutrients, and even the next generation of salmon who feed on the plankton, who feed on the salmon nutrients. And juvenile salmon survive in greater numbers when their waters are enriched by salmon carcasses. The legacy of salmon extends to nearly all life in Katmai. There are fish that transcend boundaries between the ocean and the land in a way that few organisms can. In this wounded world, during an era of mass extinction and human-driven climate change, Bristol Bay's sockeye salmon are an increasingly rare example of a healthy ecosystem functioning at its full potential. Bristol Bay and Katmai and the habitats that support salmon represent the last great salmon run on Earth. It offers a stark contrast to the state of salmon elsewhere in the United States, where nearly all salmon runs outside of Alaska especially exist at fractions of their historic highs, and many are at risk of extinction. And we could lose salmon and what we value at Brooks River to incompatible development like mining in Bristol Bay. Salmon populations will almost certainly suffer from the impacts of climate change as well, especially in areas where their populations are already threatened by habitat loss and are growing need for water, whether that's recreational need, industrial need, domestic need, or agriculture. Yet this is one more reason, I think, to demand that our governments take meaningful action to address the impacts of climate change. And I'm going to pause here to stop sharing my screen, because as I conclude the main part of my broadcast, I just have one final thought to share with everybody. And that's when salmon disappeared in the past, it was typically thought of, just to be a matter of aesthetics or economics. And now we know that when we lose salmon, it's also a tremendous cultural and economic loss. The fact of the matter is, without salmon, people wouldn't visit Brooks River to catch trophy-sized rainbow trout or to see one of the largest concentrations of brown bears on Earth. Brooks River would not have supported indigenous peoples for nearly continuously for the last 5,000 years. And modern Bristol Bay would not support a multi-billion-dollar sustainable fishing industry. And certainly you wouldn't be watching brown bears on a webcam. None of these things would exist at Brooks River without salmon. So for salmon, for the organisms that benefit from them and depend on them, including ourselves, let's work to support sustainable fisheries, protect healthy watersheds, and mitigate the impacts of climate change to ensure that the survival of salmon and their ecosystems they enrich continues long into the future. Thanks for listening to me today, everybody. I enjoyed talking with you about salmon. I'm going to try to get to, I think, a few viewer questions. As long as my voice holds out, that's been a lot of talking over the last hour. So if you stuck with me, thanks for being here. And let's see what you're interested in learning more about salmon. I didn't actually answer this question during the first part of the broadcast when we talked about sort of like the life cycle of salmon. I did mention that salmon return to their place of birth to spawn, but somebody was wondering, why do they return to the place that they were born to spawn? And that's always an interesting question to think about, because a lot of salmon pass up a lot of great spawning habitat on their way to the place that they were born. So scientists have looked at this, and we know that the majority of salmon go back to the same streams where they were born. There's a small percentage of them that will stray to a different watershed, and that maybe or a different part of the stream, and that helps them to colonize new habitat when it becomes available. But when you think about it from the salmon's perspective, maybe the gravel that they see as they're swimming by looks good to spawn, but they don't know if the conditions will be great in that spot to support their eggs, the incubation of their eggs. Or maybe they don't know if that the area in that vicinity after their eggs hatch will be a good habitat for for baby salmon. So really the only place they know where they can find those conditions, and the only evidence for that, is their own place of birth, because they have themselves as evidence. So that seems to be maybe like the logic, and they're not reasoning through this like we are. Of course, it's all sort of like instinct, and it's just ingrained in their genes, and they've evolved that behavior. But the only place that they know provides the right set of conditions is their place of birth. But there are, again, like I mentioned, a small number of salmon each year that will stray to different habitats, and they're taking a great risk. But if you time it right and you colonize new habitat, eventually, maybe your genes are going to be spread among, millions of fish. Because at one point in time, there wasn't salmon spawning in Naknek Lake, for instance, because it was covered in a glacier. Naknek Lake is basically a glacial basin. And as the glaciers retreated, some salmon found their way up into that stream or up into that watershed. And now, their genes are probably among the millions of fish that come back each year. And what about the timing of salmon spawning? Somebody was wondering about that as well. Have all of the salmon that will come back to Brooks Falls gotten there now? Yes, that's certainly the case with salmon at Brooks River. It's really a summertime run. So salmon arrive in summer, although the spawning is often delayed until late summer and fall, and that includes all of the different species that will spawn in Brooks River. So sockeye are the majority of the salmon that return to Brooks River to spawn. The second most abundant species are silver salmon. Sometimes they're called coho salmon, depending on where you are in North America. So it's a summertime run, although spawning will take place in late summer and early fall. And that differs from other parts of North America, for instance. If you want to think about like the Olympics, parts of the Cascade Mountains, and also even into California, especially, a lot of the salmon runs in those areas are wintertime runs, where the salmon are taking advantage of greater rates of precipitation in those habitats, so that it's more easy for them to migrate, I believe. And when is the season when bears run out of salmon to eat? Well, it's not yet, but it's coming up. It's coming up in a few weeks. Peak numbers of bears at Brooks River for the late summer fishing season, that generally happens around late September, early October. And then we'll start to see a slow decline in the number of bears that, excuse me, at Brooks River. So there's a lot of great bear watching to look forward to, including throughout Fat Bear Week, which is coming up on September 29. And do salmon travel at night as much as at daytime? That's something I'm not sure of, to tell you the truth. I know that their spawning efforts often continue throughout the nighttime hours, but they have to, when they're migrating upstream, they probably have to be able to see where they're going. So they're probably doing it more during, daylight hours than they are at night. But in the middle of summer in the Katmai region, it doesn't really get completely pitch dark. It's dark at this time of the year, but there's still usable daylight throughout the nighttime hours, especially early in the salmon run. So I don't think they experience the true darkness at that time of the year, and maybe that allows them to continue the migration. So even though they might be smelling their way back to their place of birth, they still need to be able to see obstacles like logs and waterfalls and things like that. And I did mention earlier that the Bristol Bay salmon fishery is a sustainable fishery. But the fishery does affect the salmon run overall. It does take a large percentage of the fish each year, and the fisheries managers for the state of Alaska are very careful to make sure that they meet the escapement goals for each one of the large watersheds in the Bristol Bay area. So for the Naknek River, that generally means anywhere from like 1 to 2 million fish per year that would be considered to be like a sustainable number of salmon coming back into the watershed. The last several years, we've had many more fish than that coming back into the Naknek River area. So it's really important to make sure that people aren't catching too many fish, because that was one of the things that really destroyed salmon runs in other parts of North America. But luckily, people learned their lessons in other places before that happened at Bristol Bay. So right now, the salmon fishery, while it takes a lot of salmon, it is a sustainable salmon run. And the fisheries biologists for the state of Alaska are also looking at how many fish predators might might eat before salmon spawn. So that's something that they do in their calculations and their modeling when they're looking at what might be a sustainable number of fish to let go upstream. Let me look at the rest of the questions here. I'll try to, there's just 3 more in the queue here. I'll try to answer those quickly before I sign off. Is there a large percentage of salmon that are able to successfully jump Brooks Falls? And yes, that's the short answer. It really looks like not a lot of salmon make the jump, but eventually I think all of them that want to will, unless a couple of things happen. They batter themselves silly on the rocks, they get injured that way, or they get intercepted by a bear. But most of the jumps aren't successful. You can clearly see that when you're watching the webcams and you're seeing salmon pop out of the water. Most of the jumps aren't successful. And I was curious to know just what percentage of the actual jumps are successful. So over a number of years, I counted fish jumping, and at the same time, I counted the number of fish that successfully made the leap. And it was really somewhere like around 6 or 7% of the jumps were successful. And I think what that means is that the salmon have to try many times. You know, there's no other waterfall that they experience on their way upstream like Brooks Falls. So this is kind of like a new thing for them. Even though they might have tumbled over it on the way out to sea, they didn't really stick around to figure it out. They weren't looking at it like, hey, well, I got to remember what's the best pace to jump this when I come back. No, they're very interested in just getting out to the ocean because things are chasing them and trying to eat them at that time. So they just have to probe the waterfall and try again until they are successful or they die trying. And I think that's one of the amazing things about fish, these fish, how determined they are to reach their spawning site. And another question here, second to last, are salmon runs as drastically impacted in other countries as in the US? I'm not sure. That's a good question. I'd have to look up to be more specific. I know that like in Kamchatka, for instance, there can be a lot of successful spawning runs. There are also salmon that spawn as far south as Japan in, so on the other side of the Pacific Ocean. Anytime that we have, large scale development, then that can impact salmon negatively. So it's quite possible, and definitely in places in British Columbia too. British Columbia this year was definitely in the news in early summer because of that amazing heat wave that hit the Pacific Northwest, and that heat wave was not good for salmon at all. If you're a sockeye salmon and you're going into the Fraser River when that heat wave hits, man, that's bad news for you because the river temperature just skyrockets, and it's really hard for you to migrate when the water temperatures are warmed into the 70s or higher. So Canada, has certainly issues with some of their salmon runs as well. So, and Bristol Bay, again, in Alaska, really is that sort of like that guiding beacon that can show us what salmon runs can be like when we protect these places. And one final question here, how does salmon physiology change from being able to go from seawater to freshwater? And that's also really a fascinating thing about salmon as well. They're able to live in freshwater and saltwater, depending on what time of life they need to do that. When they're going out to sea, what happens is their bodies transition into one from sequestering salt from fresh water and trying to keep salt in their bodies to one that is trying to keep salt out of their bodies and excreting a lot of salt through their gills, for instance. In freshwater, salmon are not drinking any water. They're absorbing enough water through their gill membranes, and then and they're also urinating a lot of water. That's kind of like the opposite thing that happens in saltwater. In saltwater, the salmon are trying to prevent salt from coming in through their gills, and they're if they do urinate anything, it's really concentrated and has a high salt concentration. They're also trying to resist absorbing salt in their digestive tract during that time. So they're kind of switching things over. One of the things that happens also when they return to freshwater is that their digestive tract doesn't really fully transition back to that freshwater existence. So even if there were things for the salmon to eat in freshwater, when they return to spawn, they might not be able to digest it because of they haven't fully transitioned their bodies over. They're just so focused on spawning and migrating that they're putting all of their energy into that, and it's just not worth the extra energy to maybe fully transition their digestive tract and look for food. So great questions, everybody. I hope everyone enjoyed the conversation this evening about salmon. They are one of the most important and impactful species of Katmai National Park and the North Pacific region, and throughout the North Atlantic as well, as we think about Atlantic salmon. My name is Mike Fitz with explore.org. Thanks for watching. FEPR Junior starts tomorrow on feprweek.org, so please go over there and get the vote out and campaign for your favorite bears. I'll talk to you tomorrow during some of our other live events, and have a great day.